Well, hey guys, so here we're going to be looking at the lesson of what is a vector, and our agenda today is to be looking at first our warm-up question here, and then look at a very brief reading on what a vector is, a brief review of the Pythagorean theorem, looking at a activity that is finding the resultant vector using our beautiful city of Chicago next to us, and just some final thoughts on vector. So looking at our warm-up question, just a reminder of what our last lesson was on, which is velocity. So what is the definition of velocity? Is it A, speed in a direction, B, the sum of all the changes of the speeds of an object, or C, both A and B? And our answer would be, wait, let me go back here. Our answer, if I can get my little pens up, our answer would be A, speed in a direction. So any questions on that, let me know. Or look back at our previous lesson. So looking on, the lesson, our objective for our lesson is we're really going to be looking at what a vector is, what a resultant vector is, and how to draw out representations of vectors. So without further ado, let's move on. Let's do some reading here. In physics, one way in which one of the ways in which we measure velocity is with vectors. Vectors are arrows that represent the direction and magnitude of certain objects' velocity. Let me underline that. Vectors are arrows that represent the direction and magnitude of an object's velocity. We use these to make it possible to add and subtract velocities in a two-dimensional manner. You can see basic example of vectors by looking at the four examples to the right. They're to the right here. I just made a vector. Looking at vector A and B, they're equal because they're both in the same. So yeah, we're looking at these two guys. These guys are both the same exactly. So yeah, they're equal. Vector C and D are not the same because even though they are the same length, they are in different directions. When we look here, these guys would be actually canceling each other out. Cancel each other mathematically. Just an example of what a vector might be. Example of a resultant vector. Suppose that you're walking home from school. You're walking to school from home. But you have a few options to take. So you're walking to school, and you can walk. Let me just click through. You can walk 2 kilometers south. You can walk right here. You can walk 2 kilometers south and 4 kilometers west to school, or you can end up walking 1 kilometer down this block, 2 kilometers down this block, and 3 kilometers down that way. Either way, they all equal the same distance. So just like using different paths, you go the same distance even though it might seem longer or shorter. In each case, displacement, this is actually what we call displacement vector, is the same. This is called a resultant vector. Resultant vectors are equal to the sum of two or more vectors. Ooh, that seems important. Resultant vectors are equal to the sum of two or more vectors. Very brief reminder of the Pythagorean theorem. When we have two or more resultant vectors, we might have to use the Pythagorean theorem. So just a brief one. I want you to measure A and B here. This is B squared, and then figure out to see the length of if it equals up to C squared here. See if it equals up to C squared. So A squared, and B squared is equal to our C squared here. So if you need help with any of the math, let me know, and we'll go from there. With this, there's just one typo with this here from my old lessons here. So this is actually Pershing. Before we go on, I don't want us to let me Let me put that a little bit so it's out of the map way here. This is actually, let me do it this way. I just made a vector. Pershing. Okay, so here we go. So in this activity, what I want you to do is we have this chart to the left and the map to the right, and I want us to add and just use this compass rows here to add and subtract vectors to get a resultant vector. So if you are just like if a graph here, what we're going to be doing is that if you are going to the right or up, we're going to have a positive in a positive direction, and if you're going to the left or down, we are going to have a negative direction and a negative direction. So we are first going to be starting at right here, Ashland and Cermak, and we are going to be going, the first step, we're going to be going to 5600 North Pershing and 1600 West Ashland. So 5600 Pershing, I'm going to be going down. So I'm going to be going down to Pershing, and I'm on Ashland. Okay, and so here, how many blocks did I go? I went 2 blocks, so negative 2 meters per second. Okay, so now we're just going to use the unit of velocity, even though it might not quite match up that quick if you're going down a city block, but it just is a good representation. So now the next one, I'm going to look here and I'm going to find Pershing and Pulaski. So I'm on Pershing and I'm going to go over to Pulaski. I'm going to end up, I'll use a different color for going west. So I'm going to go 1, 2, 3 blocks. There we go. So that's a negative 3 meters per second going west. And then I'm going 71st Street and Pulaski. So I'm going to be going down again. 71st Street and Pulaski. 71st and Pulaski. How many is that? 1, 2, 3, 4. So that's a negative 4 meters per second. 71st and Harlem. So now I'm going to be going, Harlem is all the way west here. So I'm going to be going west here. Okay, how many? 1, 2, 3, 4. So I'm going to be going negative 4 meters per second. So right now we have all negatives. We've got negative. Now I'm going to be going all the way up to the north side, Howard and Harlem. So let me get a different color here. Let me get like purple here. Going all the way up. Wow, how many blocks is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 meters per second. Okay, so I'm going to have you finish the rest there, but I think you get the idea. Okay, add them all up too and see what the resultant vector, if it was positive or negative. Okay, so looking at our final thoughts here, what is a vector? Vectors, I want you to do the readings. I think you're going to get a lot from that, but just briefly, vectors show, they show the direction of velocity. They just show our direction of velocity. And to do that, when we talk about on a one-dimensional surface, we have to use arrows. And sometimes when we end up having multiple directions, we have to use the Pythagorean theorem. And there you go, guys. So do those readings and let me know how it goes.